Video, we'll try to understand the concept of center of gravity. Until now, we have understood that when you have a body and you have a fulcrum wherein we can rotate about that point, and then you have a weight placed, the only condition that it could be in equilibrium is that entire rod, entire system would be in equilibrium when the anti-clockwise moment about that fulcrum is equal to the clockwise moment about that fulcrum is equal. I mean, both the anti-clockwise and the clockwise moments about the fulcrum is equal. Then you will get this rod or this body or this system in equilibrium. Well, so here's the point. When you have any body and we have such a situation that gets balanced, suppose I take this duster and I try to balance it with my finger acting as a fulcrum at the point, and I find that this at any instant of time, at any one single point, it remains in equilibrium, right? Let me try this and try to see if we are able to get this point correctly. Yes, it gets balanced momentarily, right? If I shake my hand, it's going to go somewhere. Well, so how it's getting balanced at that point? Which means that at that point, the anti-clockwise and the clockwise, they are getting balanced each other. But here comes the question. If I were to consider a body, suppose this is a body, and I try to imagine that this body is having a lot of particles, certainly, and every particle has a mass. So if it has a mass, then we know that there's a gravitational force, right? So when you have two bodies, one body is now the earth itself, and the other body of particles that's there, that's the another body which again has a mass. So there's going to be a force of attraction. That is what we call gravitational force, right? And Newton's universal law of gravitational force, we know that it is directly proportional to the product of masses, inversely proportional to the square of the distance between. So these two bodies are going to attract. So every particle is going to get attracted by the earth, right? And it's attractive force. So the point is, if all the forces, all the particle is acting downwards, which means that what exactly is the weight we are trying to figure out? Which weight are we trying to consider here? Which one? This particle, here particle, it's some irregular shape we have. So we found that at any point in this entire structure, we find that we are able to balance it, as we have seen in case of duster. At any point we are able to see that this gets balanced, which means that whatever torque, whatever moment of force these weights are exerting, right, this is getting counterbalanced by those which are in this part of the body. So anti-clockwise moment is going to get balanced with the clockwise moment. So that's the reason, because there's one point which is acting as a fulcrum. So can we consider that these individual weights that we have should be equal to all the weights that we assumed with some particles here in a form of particles? All those weights constitutes the weight of that body, and this weight of the body, if it is acting at this point supposedly, and at this point the body is getting balanced, which means that the moment of force at this point is 0, but the force is W, which is the weight of the body, and the torque about this is going to be 0. So this point has a name, and that is what is known as center of gravity. So the center of gravity is that point wherein if you balance this body, it will be balanced about this point. So we are considering this, that the entire weight, as if, although it's not a point object, but if we consider this to be all the weight summed up to this, acting at this point, and this is getting balanced at that position, at that point, then this point at which we supposedly assume that all the entire weight is concentrated here is known as center of gravity. So what definition can we write? We can write the center of gravity of a body is the point about which the algebraic sum of moments of weight of all the particles constituting the body is 0, and it can be considered to act at this point howsoever the body is placed. Howsoever you placed at this point, it's going to get balanced. So this point has a term, and that is what is known as center of gravity. So that's the whole concept behind it. Now let's consider a few objects, right? Suppose we take a circular ring, we take a circular disc, we take a rectangle, and then we try to figure out where's that center of gravity, where it's getting balanced. So that point in case of circular ring is the geometric center. Similarly, in case of circular disc, it's going to be at the center. In case of rectangle, square, parallelogram, we find that G, that point, is the intersection of the diagonals, center of gravity. So rectangle, square, and parallelogram, the intersection of the diagonal gives the point of center of gravity. If you consider a rectangular lamina and you draw the medians, right? The median is all from the vertices. If you drop a line to the base and it bisects the base, then the point of it, then correspondingly we will get 3 medians, and the point of intersection of 3 medians is the center of gravity in case of triangular lamina. Lamina means a very thin, negligible thickness, and it's in a plane. Well, if you consider a cylinder where the center of gravity lies, if you consider the axis of the cylinder that divides this cylinder into symmetrically 2 parts, the midpoint of this axis of this cylinder is the center of gravity. Similarly, in case of rod, if you take if you consider this to be a one-dimensional object, the rod is exactly at the midpoint of this. The center of gravity is at the midpoint of this rod. So these are some essential things that you should know about center of gravity. Well, in the next video of this, we'll be talking about uniform circular motion. So watch that video. Thank you.